Okay, so today we are going to see about the vector form of Coulomb's law in another topic, electrostatics. Okay, right. As we know the Coulomb's law, the force is directly proportional to the product of the two charges. So if you consider two charges Q1 and Q2, the force is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. So here, let us see the vector form of Coulomb's law. This is Q1. So this is the position of charge 1 and this is the position of charge 2. So this charge 1 is considered as Q1 and it is considered as Q2. So these are the two positions of these charges. Now, as you know, the points will be connected from the origin, then O to Q and O to Q2. So that is given by the position vector R1 and this is R2 vector. Now, these two charges, they have their own effect on each other, that is the force. So the force exerted by F2 by exerted by Q2, that is charge Q2, due to the charge Q1 and the force exerted by Q1 due to Q2. Okay, now let us see. So both has their own impact on each other. Now, the force due to Q1 that is given by F1 and this is the force exerted by Q1 is F1 and the force exerted by Q2 is F2. So here the vector is given, there is A12. The distance between Q1 and Q2 is that is given by R12 distance vector, and if it is considered from Q2 to Q1 then it is R21. Okay, so it is not mentioned here. So that will be in the opposite directions. If needed, we can draw this here, R21 vector, and the unit vector that is A21 vector. So this is A12 vector. Okay, so that's all about the vector. Now, the force exerted this force is mentioned as F1 to exerted on Q2 by the charge Q1. Okay, so Q1, the force exerted by Q1 on Q2. Okay, so how can we write this? So it can be written as F12 that is equal to Q1 Q2 divided by 4 pi epsilon naught. So it is 1 to R12 square into the unit vector A12 vector. So this unit vector, it is given by A12 vector is equal to the particular distance vector R12 vector divided by modulus of R12 vector. So as we know the unit vector formula, so that is here. Now you apply this here. So modulus of R12 means Okay, so that we can write like this. So already R12 uh, square is here. So here you can write Q1 Q2 by 4 pi epsilon naught modulus of R12. So already on R12 square is there. So R12, so R12 cube into this R12. Okay, so this is the force F12 exerted on Q2 by the charge Q1. Now let us see for uh, the force exerted by Q2 on Q1. Okay, so F21 is the force exerted on Q1 due to the charge Q2. So which is given by, so there we have taken the force as F12. So here it is F21. So that is equal to, you can write the product of two charges Q1 Q2 divided by 4 pi epsilon naught. So here in the R square we have to write R21 square, R21 square into the unit vector A21. So here this A21 is given by R21 divided by modulus of R21. So similar to the previous one here. Since the vector direction is changed, we are changing these values also. 4 pi epsilon naught R21 cube into R21 vector. Okay, so here to put the vectors. Okay, so what we observed here is the force F12 is equal to just the opposite of F21. So F12 is equal to minus F21. So these two forces are equal but in the opposite direction. So let us note some points. So from the figure, this is in the first slide, from this figure, F12 is equal to minus F21 and second point, like charges repel each other and unlike charges attract. And then third point, so this Q1 and Q2 must be static. So to verify this Coulomb's law, it must be a static charge, not a movable charge. So as topic name mentioned, that is a unit name, electrostatics. So static electricity, the two charges will be static. It won't be movable. The signs of Q1 and Q2. Q2 should be taken into account. So these are the important points to make note of. Okay, so what are the observations we made? So that's all about the Coulomb's inverse square law. We have seen the theoretical part as well as how it is explained in the vector form. So now let us see. So let us move on to the next topic, electric field intensity. Electric field intensity. Okay. So what is electric field intensity? So let me write the definition first. The electric field intensity is the force exerted per unit charge. Okay, so this can be mentioned as electric field intensity or the electric field strength. Okay, so the force exerted per unit charge. Force exerted per unit charge. Okay, now let us again write the force experienced based on the Coulomb's law. The force, so each charge can experience some force. So force experienced by the charge Q1 due to Q2. Okay, so here it is taken as Q2 due to Q1. So it is given by the Coulomb's law. So in the previous case also we have seen that. Okay, let's write that F2 is equal to Q1 Q2 by 4 pi epsilon naught R12 square into A12 vector. Okay, so now listen to the first definition. The electric field density is the force exerted per unit charge. Okay, so force experienced by the charge Q2 due to Q1. Okay, so how the per unit charge. So here we can write as the electric field intensity so that is given by E is equal to F2 divided by Q2. Since Q2 is exerting the force due to Q1, so this value is divided by Q2. So Q2 get cancelled. The remaining term will be Q1 by 4 pi epsilon naught R12 square into A12 vector. Okay, so this is about the electric field intensity. And now let us see about the unit of electric field intensity. So as per the definition, you know that the force exerted per unit charge, you know the unit for force as well as charge, like here, force and charge, force, charge. So let me explain the next slide. So here, so unit of electric field. Unit of electric field E vector. So it is given E is equal to force per unit charge. You know that for this force it is Newton, and charge it is Coulomb. Okay, so while writing in the unit form, say unit, the symbol is capital, but when you write it in the full form of the unit, that is small letter Newton and Coulomb. So Newton per Coulomb is the unit for electric field. Now, the electric field due to discrete charges. So that is our next topic. Electric field due to discrete charges. So we have discussed about the electric field due to only one charge. Now, what is the electric field due to discrete charges? More number of charges. Okay. So here for this field, consider a point as P. Now, so we have to consider the charges in different orientation. So this is Q1, Q1, Q2, Q3, and this is Q4. So we have considered 4 charges. Okay, so the vector is given by A R1, this is A R2, A R3, and A R4. So now we want to find the total electric field intensity at the point P. Okay, so the electric field intensity, that is the force experienced at the point P due to all these charges Q1, Q2, Q3 and Q4. Okay, so the total electric field intensity, let me write it here, the total electric field intensity at the point P is the vector sum of the individual field intensity. Individual field intensity. Okay, so what is that? that is E is equal to E1 vector, that is the electric field due to Q1, plus E2 vector plus E3 vector plus E4 vector. Okay, so since we considered only 4, uh, up to 4 is enough. So if you have more number of that, so it will extend it up to plus En vector. So here, as you know, what will you get? Q1 divided by 4 pi epsilon naught R1 square plus Q2 divided by 4 pi epsilon naught R2 square plus plus Qn divided by 4 pi epsilon naught Rn square. Okay, so here it is divided by the unit vector AR1 vector, and here it is AR2 vector, and here it is multiplied by ARN vector. Okay, so this can be in short, it is written as E is equal to, so 1 by 4 pi epsilon, so that is common summation of I is equal to 1 to n, so it is given by Qi by R I square into A or I vector. So we will get the total electric field intensity. So whatever the number of charges there, you will get the value. So this is the final step. Okay, hope you understood. So let me explain the different types of charges and their distribution in the next video. Thank you, students.